Hello, this is Dr. Eddie Morgan over at Clovis East High School, here to help you with your homework tonight. We're looking at Math 1 homework, worksheet 2.6. Remember, each problem on the homework help mirrors a problem on your homework tonight. So if you have a particular problem, you can fast forward to that problem and get the help you need. So let's get started. The first problem asks us to identify the domain and the range of this relationship, these values. So the domain is all the x values, all right? So if I look here, remember each of these is xy, 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 xy. So if I look here, my domain is going to be -2, -1, 0, and 1. That's my x values. My range is going to be all of my y values. So there's the second number in each ordered pair. So I have 5, I have 7, I have 9, and 11. Now it asks us to represent this with a mapping diagram. So very simply, I'm going to put x and y, and I'm going to map them here. And my x is going to be -2, -1, 0, and 1. And my range is going to be 5, 7, 9, and 11. And then the mapping, I'm just going to draw a line from one to the other. So 2 maps to 5. So I'll just draw that line there. -1 maps to 7. 0 maps to 9. And 1 maps to 11. Okay. Notice that every x just goes to one y. And when that's the case, we can say, yes, this is a function. Every x only has one value. In the second problem, we're asked if the relationship shown in the graph is a function, and we're asked to use the vertical line test. Remember, a vertical line goes up and down like this. So what we do is we draw vertical lines, and what we're looking for, does it ever cross the graph more than one time? Notice if I draw that line, it only crosses once. If I draw it here, it only crosses once. If I draw it here, no matter where I draw it, it only crosses one time. So I can say, yes, it is a function. Graphically, we're saying for any value of x along here, there's only one value of y. Number 3 asks us this question: what is f of 2 for the function f of x equals 3x plus 2? Simple way to do this is first write down the function. The function f of x, this is not f times x, this is f of x, it's a function notation, equals 3x plus 2. So if I want to find f of 2, all I do is put 2 into each value of x. So that's 3 times x, so 3 times 2 plus 2. So we do multiplication first. 3 times 2 is 6 plus 2. And so our answer is 8. F of 2 equals 8. Now for number 4, we're going to do the same thing we did in number 3, except we're going to do it for the whole domain. So this time, instead of giving us one value, they're giving us 5 different numbers for x, and asking us what's the range is going to be when I plug each of those in. So for example, let's start with 9. So f of -9 is going to be 1/3 times, remember f of x here equals 1/3 x, so f of 9 is going to be 1/3 times -9. All right. So 9 divided by 3 is 3, and we have a negative, so -3 is going to be that one. Now we do the same thing for f of -3. So 1/3 times -3. 3 divided by 3 is 1, but I still have a negative times a positive, so it's negative. F of 0 is going to be 1/3 times 0, which is simply 0. And then f of 3, 1/3 of 3 is going to be 3/3 is going to be 1. And f of 9 is going to be 1/3 times 9. 9 divided by 3 is 3, positive. So my answer is, what's the range? Well, the range is going to be, and we use our set notation here, -3, -1, 0, 1, 3. And that's our answer. For number 5, we're simply asked to write this equation, y equals fx plus 9, using the function notation. All we're going to need to do is substitute the y for f of x, since it is a variable in x. So my answer is simply, in function notation, f of x equals 5x plus 9. Just emphasizing again that the answer here is a function of a variable x. X, again, is the independent that determines the function, which is the dependent variable. Problem 6 is compare and contrast. You can use a mapping diagram or the vertical line test to tell if a relation is a function. Which method do you prefer? Well, both methods are good. But which do you prefer? The mapping, that works best if you have a table. Or a set of points. Because in this case, to use the vertical line test, you would have to graph it first. The vertical line obviously works best when you have a graph. It's very easy on a graph. One advantage the vertical has over the mapping is the vertical shows the whole function, not just any points on it. You could have a function, if not all the points are listed on the table, you might not recognize it's not a function. All right? Problem 7 is an error analysis problem. It says a student drew a dashed line on the graph shown and concluded that the graph rested on a function. You can see the dashed line right here. And notice where he drew the line, it only crossed one, so he concluded it must be a function. However, his mistake is you have to apply the vertical line test. To the whole graph. And if you look here, if I were to choose another point like right here, notice when it went right there, it actually crossed the graph 3 times. So the answer is this is not a function. I usually just kind of take my pencil and line it up vertically and just walk across the graph and see, is there any point that crosses it twice? Problem 8 is a lot like problem 1. They want us to see, is this a function? Is there any x that shows up twice? Well, one way to kind of make sure is to make yourself a table. So I'm going to make a table here with my x and a table here with my y and then map them. My x goes 1, 3, 4, 3, and 2, so I have 1, 2, 3, and 4. I should already notice that I've got 3 showing up twice. That should tip me off that this is not a function. But let's go ahead and map it anyway. All right. My y values are 5, 2, 8, 4, 3. So if I put those in numerical order, I got 2, 3, 4, 5, and 8. So let's map them. First, 1 goes to 5. So I map 1 to 5. 3 goes to 2. 3 goes to 2. 4 goes to 8. 3 goes to 4, and 2 goes to 3. And you notice right here the number 3 goes to both 2 and to 4, and therefore it is not a function. Problem 9 asks us to make a table that represents a relation that is not a function. This is pretty simple. I can just make a table x and y and make me a nice table here. And I can make some x values. I can go 1, 2, 3, and I can assign them to any numbers I want. I can say 5, 7, 9. All I have to do to make a function is to make sure that I get one of these values twice. So like if I take 2 here and put another 2 here, and instead of going to 7, I go to 11, you see now if I'm mapping, my 2 is going to go to 7 and it's going to go to 11, and it won't be a function. So all you have to do is make a table where x shows up twice with a different answer. So why is this not a function? Value 2, x value 2, has 2 y values, which means not a function. So if you ever have an x show up twice in your table or in your events and it has a different value, then it's not a function. Problem 10 asks us to think about a plan. In a factory, a certain machine needs 10 minutes to warm up. It takes then 15 minutes to run a cycle. The machine can operate for as long as 6 hours per day, including the warm-up time. So draw a graph showing the total time the machine operates, including one day, as a function of the number of cycles that it runs. What's the domain and range that are reasonable? Well, the reasonable thing, for example, first of all, it can only run 6 hours. Well, how many minutes is 6 hours? Well, 6 hours is 6 times 60 is 360 minutes. So my time here, my range, should be between 0 time and 360. That's as much as it can go. All right. Now the question is, what's going to be the number of cycles? Well, first of all, since the cycles are 15 minutes long, if I take 360 and divide by 15, I find out that it could run 24 cycles. Although in reality it would only run 23 plus a 10-minute warm-up. All right. So, but as a range, I might, as a domain then, though, the number of cycles, I might make my domain then, the number of cycles, less than or equal to 24. It's probably not going to go to 24, but that's my range. Okay? So that's my range, that's my domain. And you can see the graph here. Notice that it doesn't start quite at 0. At 0, it's taken 15 minutes, 10 minutes already been used for warm-up, and then it doesn't quite get all the way to 24. Notice it here, it stops at 23. And you can see that indeed it is a linear function. Okay? Problem 11. A theater group is having a car wash fundraiser. The group can only spend $34 on soap, which is enough to wash 40 cars. Each car is charged $5. So there's our parameters. If C is the total number of cars washed and P is the profit, which is the independent and which is the dependent? Does the profit depend upon the cars washed, or does the car wash depend upon the profit? And obviously in this case, A, the C, the cars washed, is the independent variables. The more that I wash, the more that I get, profit that I get. And P is dependent upon how many cars. The more cars I wash, the more money I make. All right? Is the relationship a function? Well, B, yes it is, because for every car washed, there is only one value given to it. There's a unique value. When you wash 10 cars, you make a certain amount of profit. You don't make $50 and $60. You make a certain amount, one amount. Write an equation. All right. The equation is, notice that first of all, my profit is going to equal, how much do I get for each car? Well, it's going to be $5 times the number of cars I wash. But then I got to remember that I spent $34 here for soap. So that comes out of my profit. So I'll end up subtracting that. And so my equation will be 5n minus 24. And the last question, what's a reasonable domain? Well, the reasonable domain is, first of all, domain is how many cars I wash. Well, notice here that I can only wash 40 cars because of the soap. So my domain is going to be between 0 and 40. That's the most I can have. Now for the range, obviously, if I don't do anything, I can get 0. But what's the top that I can do? Well, the top is if I put in 40. So let's take our equation and put in 40. 5 equals 5 times 40 minus 34. So we get the profit equals 200 minus 34. So the profit is going to be 166. So a reasonable range would be up to 166. The last problem, we can work like problem 1. Let's make a table and just match them. So notice if I make my X and my Y, I have A, B, C, and E. So my X's are A, B, C, and E. My Y's are B and A, C and D. So A, B, C, D. So A, B, C, and D. Just put them in alphabetical order. And now let's map them. A goes to B. So A goes to B. And then B goes to A. So B goes to A. So far, so good. C goes to C. And E goes to D. So notice every value of X goes to one value of Y. There's no duplicates here. And there's no value of A that goes to two numbers. So we would say, yes, this is a function. The relation is a function. All right, that's great. I hope it helped. Good. Have a good day tomorrow in school.